Circumference and arc length. What we're going to do is start with the concept of circumference and then extend it out into what is called arc length. For the most part, you are probably already pretty good with circumference. In fact, you probably already know the formula and have used it dozens of times by now. What I'm going to do here at the beginning is discuss where the formula comes from. Okay, the definition of circumference is the perimeter of the circle, which is really just the distance around the figure. Okay, and I'm going to make a couple observations to begin with here. Okay, the thing about a circle is a circle. There aren't different forms of circle. They all look exactly the same, except that they could have a different size. So all circles are going to be similar. To be similar means that they have the same shape. The only difference that they can have here is their size. Okay, their size is going to be dependent on only the length of the diameter or radius, which in a sense are kind of the same thing. The diameter is the measurement across the figure, the radius is the measurement from the center to the outside edge. The comparison between those two is just a scale factor of 2. So if we accept that observation, we could say that any measurement within a circle is proportional to another measurement. For example, I just mentioned that a diameter is twice the length of a radius. But we can extend this into the idea of circumference. Therefore, the circumference is proportional to the diameter, and some constant value relates all diameters to their respective circumferences. Okay, so I'm not going to discuss radius here. I'm going to focus on the diameter. But whatever the length of the diameter is and the circumference, they must be related by a scale factor. In that scale factor, we're going to figure out what it is in just a second here. All right, so let's go ahead and begin with a picture of a circle. I'll start with a center point here. Go ahead and build a circle around that. All right, and in addition to that, I'm going to go ahead and draw a diameter. All right, so the diameter just needs to go through the center. That's it. All right, so we'll let that represent a diameter. And then what I'm going to do is inductively investigate the relationship between the diameter and the circumference. Okay, so I'm going to take a piece of paper here, just a piece of cardstock that I have, and I'm going to measure off the length of the diameter. Okay, so just about there. All right, so that'll represent our diameter. And what I'm going to do is I'm going to bend the paper just a little bit to give it some curvature. And what I'm going to attempt to do here is move around the figure to see how many times the diameter can be measured around that figure. Okay, so I'm going to match up that point there, move it around as best as I can to follow the curve. You might not really be able to see it, but I'm pretty darn close to matching up to the curve. And I'm going to mark off that point. So the distance from here to there is going to be 1 diameter. Go ahead and put a 1 right there. We'll call that 0 just for reference point there. Next, what I'm going to do is measure another diameter along that side. All right, so if I can get that matched up as best as possible, give a little bit more of a curve shape there. It appears to be right there. So that would be 2 diameters. All right, the other one might be a little bit tough to do. Actually, I can just bend it backwards. Do that, match up that spot there, and follow the curve. And I get here, which is ever so close to 3. Very, very close to 3. Okay, so I get 1 diameter, 2 diameters, I get 3 and a little bit of change. And if you know the formula for circumference, that might make sense. Okay, circumference, this is what you'd been taught before. Circumference is going to be equal to pi times the diameter. Pi times the diameter. Each of these is the length of the diameter. What I'd have to do is multiply the diameter by pi to get the circumference. And pi is 3.14. Pi is 3.14. So we've got 1, 2, 3 diameters and just the tiniest bit left over here that would be the 0.14, which actually isn't just 0.14, it does continue out, there's more decimals, there's an infinite number of decimals as far as we know right now. As an alternative equation, you can substitute in for the diameter 2 times the radius. So you could also mention it this way. Circumference is 2 pi r. 2 times r is the diameter. All right, so either of those you can use. It pretty much just depends on what you're provided. If you're given a diameter, you can use that. If you have a radius, you could just double it to get the diameter, then times by pi. Example 1, find the exact and approximate circumference of a circle with a radius of 9 centimeters. All right, so exact and also approximate. The thing is that our formula involves pi. So if you leave things in terms of pi, you get the exact answer. If you actually multiply by pi and then you round off the answer, that becomes the approximate answer. Okay, the formula that we do have with respect to the radius is that circumference is equal to 2 times pi times r, the radius. Okay, so if we plug in the 9, we get 2 times pi times 9. For the exact answer, what we'll do is multiply the 9 times the 2, which is going to give us 18. We would then multiply by the pi, but instead of actually multiplying by it, you would just write down behind it pi. So the exact answer is going to be 18 pi. The approximate answer is going to be when we actually multiply those numbers. So we take 18, multiply it by pi, which gives us approximately 56.5. All right, units for both of these would be centimeters. All right, so again, that's the exact. This is the approximate. Example 2, we're going to find the radius of a circle if the circumference is known to be 26 meters. So again, we can start with our formula. Circumference is equal to 2 times pi times r. Again, using that form because the question's asking us to figure out the radius. All right, so the circumference is 26 meters. So 26 is going to be equal to 2 pi times r. It is possible to divide by the 2 pi at once, but you need to use parentheses if you're going to do that in the calculator. So you could do it separately. You could just divide the 2 into the 26 first, which gives you 13 equal to pi times the radius. All right, and then you would divide by pi so that those would cancel, and you get that. Unfortunately, we don't like this as an answer, which would indicate an exact answer. So for these types of problems, we're always going to approximate. And our radius is going to be equal to, I should make a habit of saying approximately equal to 4.1 meters. As mentioned just a moment ago, you can divide by 2 pi, but when you do that, you need to use parentheses. For example, you need to do it this way. You take the 26 circumference, divide that in parentheses 2 pi, and that gives you the correct answer. If you attempt to do it without the parentheses, you divide by the 2 and then the pi like that, the interpretation that the calculator has of this is that it's going to divide it by 2, first divide 26 by 2, which will give you 13, but then the 13 is going to get multiplied by pi. It does not understand that the pi is part of the denominator, which means you're going to get 13 times about 3, so around like 40, 41. You get around 40 or 41. All right, so as an extension to circumference, we can talk about arc length. Suppose that you only need the length of a piece of a circle, not the full distance around it, but just a piece of it. That we call arc length. You can use the arc measure that we have previously talked about to proportionally find the length of any arc. For example, number 3, we're going to be working a couple problems here. The first, you have a picture here that has a diameter shown, also has a 75-degree angle there with that radius. What we're asked to do here is to not figure out the measure of PQ, which would be 75 degrees, but instead to figure out the length of arc PQ, which is going to be this. what would be the length of that if we were to straighten it out? Okay, that arc length, that piece of the circle, is going to be 75 parts out of 360 parts of the whole circle. So what we could do is set up a proportion. We could take 75 over 360, which could reduce, but if you're going to use a calculator, don't worry about it. We're going to take 75 out of 360 and set it equal to x, which the x is going to be the length of PQ, divided by the circumference, the total length around the figure, which would correspond to the 360 degrees. Okay, to calculate the circumference of this circle, we do have a diameter of 9. So the circumference is going to be 9 pi. All right, and with some cross products, we can solve for x. We'll go ahead and take our calculator and figure out this first product right here. We're going to take 75 and multiply it by 9 pi, which gives you that number, and then we'll divide it by 360. And that is x. That would be the value of x, which is approximately 5.9. All right, what I should probably do here is just write down the length of PQ equals. The length of arc PQ is going to be equal to 5.9. And we can't put the little m in front of it because that would indicate the measure of the arc, which is actually 75 degrees. All right, for the second picture, we're asked to figure out the circumference this time. Okay, but the setup can still be used here. That just means that your variable is going to be in that location. All right, we want the circumference of the circle, and what we know is that 270 degrees here, okay, that's the distance all the way around that direction. Sometimes it's hard to indicate those major arcs. Let's fix that there. Sometimes it's hard to indicate the major arcs. But the 270 degrees is going to correspond to an arc length of 61.26. So 270 over 360 is going to be equal to 61.26. Let's get that right there. 26 divided by, and you could call this x. In this case, it is our circumference, so I'm just going to call it c. All right, and with cross products, 360 multiplied by 61.26 gives us that number. We divide by 270, which gives us 81. So C equals 81.68. Units would be meters, and units over here, which I have a bad habit of writing them down, so I'll just add it in this time, would be yards. And just to throw it out there, this question could ask you to go further. It could ask you to figure out the diameter of the radius. For the diameter, you would just divide this by pi. For the radius, you divide this by pi, then divide it by 2.
Later, blah.